Good afternoon. We are in Unit 7, Day 11, Notes, Solving with Radicals. And the solving that we're going to be doing with radicals is all going to be in the domain of the real numbers, not any imaginary numbers. Okay, so we will not be graphing, but you may use graph paper if you wish. Roman numeral 1, we're going to go over the solving steps because they're actually the same for every radical that you solve. So step 1 is isolate the radical term. If there are two of them, isolate one of them. Just pick one. Okay, number 2, remove the scalar from the radical unless it complicates the other side. And we'll talk about that in a moment. You get to choose whether you move the scalar or not. Usually you will. All right, here is the money move. This is called exponentiating. You're going to exponentiate all terms on both sides by the power of 2. This will get rid of the radical. Okay, and exponentiate all terms both sides by the power of 2. And I'm going to put a side note on this. At this point, if you have two radicals, you would isolate the next radical and repeat. All right, number 4. When there are no more radicals, solve for x. So solve for x, and in this case, there will only ever be one x, but in other cases, that sometimes can change. Solve for x. All right, let's do an example. Example 1. 3 square root x plus 1 minus 6 equals 0. So first thing we want to do is get the radical term alone. So we're going to add the 6 over to the other side. So now I have 3 square root x plus 1 equals 6. All right, so now we're going to move the scalar. So this is step 2. So multiply both sides by 1/3 to get rid of the scalar because we want the x plus 1 to be alone. 6 divided by 3 is 2. Now, if the scalar is a 4 or a 1 or something that will square out nicely, we don't have to worry about it. But usually you're going to want to move it. All right, this is the money move. We're going to exponentiate both sides. So you raise both sides to the power of 2. Now I'm going to write this part out. This is why squaring both sides actually works. So when you square this radical, you now have x plus 1 radical times radical x plus 1. On the right, obviously 2 squared is 4. It's pretty easy. But we have a property of radicals that says if you take a square root of a times a square root of b, you can combine it into square root a times b. But this process not only goes forward, it goes backwards. So here, where we have two radicals, we can now combine the radicals under one big radical sign. And you have x plus 1 times x plus 1. That equals 4. So 2x plus 1's, 1 comes out, equaling 4. And then we just finish solving. X equals 3. So again, this is why squaring works, because it creates two of them that get combined, and then for every 2x plus 1's, 1 comes out. And that's why exponentiation works. All right, I'm going to flip the page now, and we're going to do a second problem, going up just a little bit in difficulty. So this is example 2. we have the square root of 3x plus 1 equals 2 times the square root of x. Now, in this case, we have two radicals. So normally we would take steps to make sure that one of the radicals is alone. However, one is already alone. This is an example of where moving the scalar over to here would just create 1/2 and make the problem more complex. So we're going to leave it where it's at and concentrate on this left side first. We're going to get rid of this radical. So we're going to square both sides. 2 3x plus 1's, 1 comes out. Over here, the square applies to the 2 and the x. So you have a 2 squared and then 2 x's, 1 comes out. So 3x plus 1 equals 4x is easy solving. Subtract the 3x over. 1 equals x, so x equals 1. There's our solution. All right, let's go up another step. This is example 3. Now it's not going to be so easy. We're going to have the square root of x plus 1 plus a 3 is equal to the square root of x minus 2. Okay, so first thing you want to do, add or subtract to isolate the radical. In this case, there are two radicals, but one is already isolated, so we're ready to go on to exponentiating. So we're going to exponentiate both sides. All terms, including the plus 3, get squared. So on the left, we now have radical x plus 1 plus 3 times radical x plus 1 plus a 3 equals, and on the right, 2x minus 2's, 1 comes out. So now we have the job of multiplying this. Radical x plus 1 times radical x plus 1 is x plus 1. Radical x plus 1 times 3 is 3 radical x plus 1. Now we distribute the 3. 3 times radical x plus 1 is 3 radical x plus 1. And 3 times 3 is a 9. That gives us x plus 1 plus 6 radical x plus 1 plus 9, which we can then simplify a little bit. 1 plus 9 is 10. So I have x plus 10 plus 6 radical x plus 1 equaling x minus 2. Now this is the point in the directions where it says isolate the next radical and then repeat the steps. So we're going to move the x and the 10 over here because we want this second radical now to be by itself. So we're going to subtract x over to the right and subtract 10 over to the right. So we have 6 square root of x plus 1 equals negative 12. Now if the x hadn't added up to 0, we would have a quadratic at the end and two answers, which is possible. All right, in this case, 6 will go into 12, so it is convenient to multiply both sides by a 6th and get rid of the scalar. Again, you do it on a convenience basis. So radical x plus 1 equals negative 2. Now we exponentiate both sides to the power of 2. 2x plus 1's, 1 comes out, and negative 2 times negative 2 is 4. So we just subtract 1 and finish solving. X equals 3. So again, on this one, you had to isolate a radical. It already was. Exponentiate, which meant a lot of multiplying for this side because it had that awkward binomial. When that's simplified, isolate the next radical, exponentiate, and get rid of that one. Okay, last example we're going to do. Example 4. This one won't have that x conveniently be subtracted out. So square root of x plus 2 plus 4 equals x. Okay, first step, isolate the radical. So we're going to subtract 4 over to the right. So square root of x plus 2 equals x minus 4. Now that the radical is alone, it has no scalar to get rid of. We're going to exponentiate. So raise the entire left side to the power of 2. Raise the entire right side to the power of 2. 2 radical x plus 2's. 1 x plus 2 comes out. and we're going to multiply this, and we end up with x squared minus 8x plus 16. Okay, so on this one, the x didn't conveniently add out. What we're going to have is a quadratic. So you have two options of attack. You can, first of all, you need to get it equal to 0, and then you need to decide, does it factor, or will we need the quadratic formula? So that's our basic attack. So I'm going to first make it equal to 0. So I'm going to subtract x and subtract 2 over to the right. So 0 equals x squared minus 9x plus 14. This one actually factors, which is nice. So I have x minus 7 and x minus 2. Solve this, set x minus 7 equal to 0, you get x equals 7. Set x minus 2 equal to 0 and solve it, you get x equals 2. Now, unlike linear equations where most of our answers are good, we need to really check these carefully. Radicals create a whole lot of extraneous. So lots of extraneous answers. And these extraneous answers will create negatives under the radical. And remember, we're doing this over the reals. So complex numbers are not an option. So I'm going to actually take the 7 and I'm going to substitute it into the original and make sure it works. So I have radical 7 plus 2 plus 4 equals 7. 7 plus 2 is 9. Square root of 9 is 3. And 3 plus 4 is 7. So that one's good. Okay, now we're going to try the 2. Have square root of 2 plus 2 plus 4. Is that equal to 2? 2 plus 2 is 4. Square root of 4 is 2. But 2 plus 4 is 6. It's not going to be a 2. So x equals 2 is not an answer. It's extraneous. So this extraneous worked as far as there being a positive number under the radical, but the left didn't equal the right. The other type of extraneous answer that you're going to run into has to do with negatives. So if your domain is real numbers, then any x creating a negative under the radical is extraneous automatically. If your domain is real, then any x creating a negative under the radical is extraneous. Why? Because square root of a -1 is imaginary, and if you are in the reals, imaginary is not a solving option. All right, that's all I have for you. Have an excellent afternoon.